Okay, recording started. Right, today we're going to do option C, and that's the last topic that we have in the whole syllabus to cross. And if you think that C is going to be easy, unfortunately there's C1, C2, C3, C4. C1, C2, C3, C4. And then C1 and C4 are the biggest. C2, C3, I can finish it in a 1 hour lesson. Or 2 1 hour lessons. It's really quite fast. Okay? C1. What does it deal with? Very simple. Lenses, mirrors, and aberration. I'll explain a little bit more over here later on. Yeah? So, but essentially, it's these three things. Hello? Excuse me? Yeah. These three things, yeah? Lens, mirrors, and aberration. Please remember these three things. So if you want to check whether you remember C1, you must be able to handle all kinds of lenses question, mirror question, and then aberration. In fact, those two first one are the first 2 points are the major ones, so the last one is really quite fast. So lens. Okay, I assume you know what happened to this when the light goes through a converging lens. What will happen to the light? Converging lens, don't go and converges lah. Converges to where? Here? Yeah, correct. Oh, you know this, huh? Let's check whether you know this or not. Da, 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 da. How? Where does it focus? So it goes parallel. So whatever angle it comes in, it just goes parallel.
If you draw a line on focal.
Okay, then you draw a line. Then you just somehow crosses somewhere here lah.
No, first draw a parallel.
Huh? First you draw a parallel line.
Sir, that it looks like this.
And then it crosses here. And then what happened?
Yeah.
Ah, correct. Well done, man. It's not gonna be that easy, huh? How? What happens after it passes through?
So we don't know where.
Die, you pass through here, right?
So where's the point source? Is it within the?
Here lah, point source is here lah.
Oh, parallel.
It's done in such a way where I think it's quite obvious that the focal length is larger than the object distance.
Oh, does it?
How? Does it even converge or not? Does it even converge or not? So how do you go about this? You do the same over here. So it will pass through here. Can? Now I'd like you to try. I'd like you to draw one ray diagram. Sorry, which one? This one? Okay, I draw a dotted line that's parallel to this. Where this crosses the focal plane, that will be the place where this light ray will bend through. Basically, I'm using that principle over there. Okay? How about trying for this one? I intentionally make this far away. I'm intentionally make this far away. Hope it's obvious enough to you. How? Yeah, just cross here. I mean, it's badly drawn, but the idea is there. So just cross. It's supposed to cross this point. So actually, I think by right it should converge even further, but just because of poor drawing, it doesn't. But actually, it should converge further. A converging beam passing through a converging lens should converge further. Just exaggerate it a bit further. It should look like this. Okay? A converging beam passing through a converging lens should converge even further. Cool? Now I'm going to give you something else that is different from this. Do you know how to draw the ray diagram to form an image? There are three rays that I need to do. No, I don't do first. You do it. Take out a piece of paper. Don't go and scratch on the table. Take out a piece of paper. Otherwise, you start writing words on the table. Draw it, draw it, draw it, draw it. In exam, you don't do this. You write. Yeah. Come on, come on. Focus, people. Focus. Focus.
For this case,
Draw the ray diagram for this
how
one.
do you locate that point? Yeah. For the last case, how do you locate that point?
This one, I draw a dotted line that's parallel to this, and then where it cuts here. I mean, it's poorly drawn. I mean, obviously, yeah. But the idea is that's the method. That's the method. Try. Let me take a walk around and see see how much damage 2 years of not touching this topic does to you. Looks like banana.
This one. Like this.
Yep. Most of you got it right. Okay. This like looks like it's going through like water kind of thing. It should be a straight line. It should be a straight line. It's like okay, three rays one ray. Okay, it passes through the center. If it doesn't pass through the center, just make the center a bigger dot. And then it goes through here. This is the image. Now there's a third ray that you need to do. This is the focal point. Yeah. So there are three rays that you need to do, draw, and then it must pass through the same point. So the image is observed over here because one point on the object forms one point on the screen. If you put a screen here, what happens is that one point on the object forms a patch on the screen. So imagine every point of the object forms a patch on the screen. It's going to be a blur image. That's what happens when you off focus. Yes.
We have to draw all three lines.
Hang on. We expect you to know all three. So in case, if you're given a free choice to draw any two, then it's fine. Sometimes they force you to use this one. Okay. You must know how to draw three in summary. I'm going to give you another form. The same thing, but in another form. It came out in IB exam before, and it just threw everyone off their chair. Look at this, Draw what happens to the wavefront after it passes through the converging lens. So draw.
You get focus on you draw the perpendicular line and follow the perpendicular line.
Basically, the task is very simple. Draw the wavefront after passing through the point over here. Actually, a simpler one. Let's go for a simpler one. Say, for example, let's go for this one first. Plane wave coming in. How does it pass?
C shape.
Let your friends try. V shape. Z shape. Yeah, that makes our marking easier. Yeah, for easy marking, we still get X dollars per paper. Thank you. I'll give you an X shape. Yeah. So the way to go about this is always to draw the ray diagram. So parallel ray passes through here, and wavefronts have to be always perpendicular to the rays. So it goes. And then after passing through here, it goes this way.
Oh yeah. So I have to draw the after.
If they didn't say stop there, then you better continue. Yeah. Wait a minute. Wait a minute. So basically, you have to know that the rule that governs the direction of the wavefront and the shape of the wavefront and the rays is that the ray and the wavefront, they're always perpendicular to each other. What you did just now is the ray. This is the wavefront. So what you need to do is to draw the perpendicular lines. Always easier if you draw the ray first, then you draw the wavefronts. Can? Cool. Then make a guess. If you have diverging lens, what happens? Let your friend try. Yeah, hang on. Let your friend try. How will a diverging lens look like? I mean, the wavefront after passing through the diverging lens. That's ray. I want wavefronts. Oh, inverse. Why not you draw? Why not you draw? Yeah. You don't have paper? I'm sure. Then what's inside that big thing that you were carrying? Come on, I'm sure you have. The whole bag just to put a thing. Come. I think you got foolscap paper. It's okay. You just flip a few pages down, you find blank sheets. Yeah. Assignment. Right. The whole bag. Whole bag. I thought you were going to say everything here. Okay, so how's the wavefront?
It's Wi-Fi signal. Wi-Fi signal shape.
Remember, wavefront has to be perpendicular to the ray. So you go like this. Can? Cool. So draw ray first. Can? Now I'd like you to consider for diverging lens, since we're talking about diverging lens, how about the ray pattern? Let's do 3 of them, yeah? So I got diverging ray, just now we went through this already, and it diverges as though it came from principal focus. Okay? Now I'm going to give you something interesting. How about, say for example, if I got this, and the principal focus is here. How does it diverge? Draw. How do you draw for this one? Diverging lens. Yeah, thank you for pointing this out. It should be this way and this way. How does it diverge? Oh, Shannon, your IQ really just jumped by 50 points, man. Yeah. You should wear the lens. Yeah. Mensa chair, man. Mensa chair. Mensa chair. Yeah. Mensa platinum. And what do you do? I want to see those two rays. I want to see those dotted lines, the construction lines. So you draw an additional line that's parallel to the two of them where it passes this focal plane is where all the light rays going to diverge as though it comes from here. Previously, the point is on the principal axis. So you got to find where on the focal plane it seems to diverge from. And you do that by drawing this construction line where it cuts the focal plane. That's the point where the light seems to diverge from. Why is the dotted line not directly in between where? Because it is shifted upward. If it is like this, it'll be right in between these two. Yeah. I mean, it depends on how much you tilt. If you tilt even more, then it will go even closer. Say if this is the focal plane, then you go even closer. Yeah, because it's the way it tilts. Yeah. Okay. Cool. Now for you to try on your own, try this. Try. A diverging ray meets a diverging lens. How will it diverge? I forgot to give you the principal focus. Say the principal focus is here. Definitely, a diverging beam passing through a diverging lens diverges more. The question is, how does it diverge? Same thing, always do construction lines. You cut here. So for this ray, it seems to come from here. Okay? Then you do the construction line for this one parallel to this, where it cuts the focal plane. It seems to come from here. Okay? A little bit messy, but the method is more or less the same. Cool. Good. Go on. Okay. Give you one last one. One last one. Yes, correct. It goes this way. Okay. If the rays are converging and it converges towards here, it is basically the reverse of this one. This converging rays.
Sorry, the lens.
Converging. Oh, okay. Again, converging, converging. Converging lens, diverging lens, and then converging beam. Okay. It's the reverse of that first one. All right, now after we've done with rays, now let's throw in equations. Okay, let's throw in equations. There are two equations that you need to know, and we'll do two questions of different level of difficulties. Let's take a look. 1 upon u plus 1 upon v equals to 1 upon f. Convention. Must remember that f is bigger than 0 for converging lens, f smaller than 0 for diverging lens. U is always bigger than 0 for real objects. We'll talk about virtual objects later. Remember all the conventions, huh? F, okay. That's good that you mentioned. Actually, when you do your lenses and stuff, right, it's good that you learn this equation so that you know the answer before you do the question. You can calculate your answer. So F is the focal length, U is the object distance, V is the image distance. Okay. Now let's try one simple question. Since some of you have never seen this before, let's try one simple question, and then we will try a more difficult question with additional formulas that you need to use. Okay? So let's try this. This image distance, object distance is 12 centimeters. Focal length is 10 centimeters. Find first the image distance, magnification, which is actually equals to, no, this one you won't know. It's okay. Just find the image distance. Will do. Give it a try. No, it's a real object, real image eventually. Yeah. Then the more philosophical question is, what is real? When you touch an object, what do you actually touch?
Nothing.
You touch nothing. Yeah, you touch nothing, correct? You touch nothing. It's only the electrostatic forces that you're feeling. Your electrons and the table's electrons never actually get to touch each other. You touch nothing. When you see, what do you see? Do you see the person or do you see the light bouncing off the person? Yeah? When you hear, are you hearing the sound or the vibration of the particles? Genius and Balaji are, I guess they are synonyms though. I guess they're synonyms. I guess they're synonyms. Yeah, because synonyms. Yeah, synonyms. You never know, okay? Some people, I've taught students before when in class they're like, but in 20 years later, 15 years later, successful, okay, in his own rights, working happily in Silicon Valley, and then I got students whom you wonder whether they're going to get STD and all. And every time you talk to them, the mind you can see is about girls and girls and girls. Now, in the VWO, helping people to raise funds to educate the people who are in the rural countries. So people change. Those kind of wow, always very righteous one. You never know, okay, down the road with the right condition, wrong people, wrong friends, wrong temptation, white collar crime. Yeah, you never know, yeah, you never know. So don't think, when you see this kind of thing, don't think too lowly of other people, neither don't think too highly of ourselves. No one can be invulnerable or totally impenetrable for sins, given the right condition. Given the right conditions. So we should be thankful that we've never been in those kind of conditions. Yeah? We don't talk about stealing because we don't need to steal. Yeah? If you're in a condition where you don't have to eat, probably you don't steal for yourself, you steal for your family. Yeah. So we should be very thankful that we don't have ourselves in that kind of condition. So confused. It's like, what has this got to do with physics? The image. Okay. Anyone couldn't get 60? Can I? Okay. Now I'm going to show you another equation. Magnification equals to height of image over height of object, which is equals to negative v upon u. Actually, it's negative over here. Negative height of image over height of object. Yes, correct, it is. So in this case, can you see that the magnification will be 60 divided by 12, which is equals to 5, which means that the height of image is going to be 5 times higher. Now, what does the negative sign mean? It means that the image is inverted, correct. Inverted, correct. So which means that are there situations where your image is upright? And what does it mean about V if the image is upright?
On the same side?
V must be positive or negative? Yes, correct. V must be negative. And that's a virtual object image, where you place your object closer than 10 centimeters in this case. Okay? Yep. Now let's try something more difficult, combining the use of this equation and this equation. Okay? An image is 3 times the size of the object. Focal length is 12 centimeters. Find the V and the U. Give it a shot. Three times the size of the object. Find the image distance and the object distance, given that focal length is 12. The object distance is 16. Yes, correct. 16. Image distance will be 48. Okay. For those of you who have done with this question, I'd like you to try a more difficult question, which is this one. Focal length equals to 6 centimeters. Find. Give it a shot. The total distance between the object and the image is 25 centimeters. The focal length is 6 centimeters. Find the two sets of values of V and U. You'll find that there are two solutions for this case. It's a real image. It's a real image. Yep, you'll find that it's just swap around, correct. But there are two sets of possible values. Give it a try. This one will be more difficult because you'll be solving quadratic equation. This one, some point of time, you have to solve quadratic. Is Yani okay? Have you? Is she alright? No? No news. Oh, you sure? I thought the two of you are like texting each other every 5 seconds time. So, what are the two values of V and U? 10 and 15. So one of them, U is 10, V is 15. The other one is U is 15, V is 10. Okay. 10 and 15, basically. 10 and 15, 15 and 10. For those of you who are done, try this more interesting question. Same setup, everything the same. Just that the distance between the object and the image is now 25, but it's a virtual image right now. Everything else the same. Find the value of U and V. Find the value of U and V. If it is a virtual image. Be very careful how you write the equation. There's one tweak. Yep, if it is a virtual image. Same value, 25, same focal length, 6. Real image, virtual image.
So the object is at the focal length, the image
Will be formed at infinity. Now what does form at infinity means? It means that you can't see it. It means that you can't see it. Yes, 5 and minus 30. The question is, if it is a virtual image, what's the object distance and image distance? This is 25.
How do I stipulate which is the sign?
If it is a virtual image, it's always negative. Yeah. Yeah, it is always negative.
So the positive is defined from counting from the object.
Yes. Now, the one way to go about this is that if your object, say, if your object distance is 10 centimeters, say, for example, not that this is the answer, say, what do you think is the value of V? If it is 25 centimeters behind, it will be?
Then 35. Yeah.
Careful, minus 35. So U plus V will become? U plus V is negative 25. The only thing you need to change is this. Yeah? So this is one way that can prevent careless mistake. One's very simple. Just throw in numbers, get a feel of how the equation works out. Can? Otherwise you end up with U minus V or V minus U equals to 25 or minus 25, which is wrong. Can? And you'll find that this one only has one solution. Yeah, only has one solution. It doesn't make any sense for you to have U equals to negative 30 in this case. Okay? Cool? Let's digress a little bit by looking at diverging lens. How does the formula work out for a diverging lens? Object over here, focal length over here, 6 centimeters, 10 centimeters. Find distance between object and image. Give it a try. Careful, read the question carefully. What's the distance between the object and the image for a diverging lens? Object distance 10 centimeters, image distance, focal length 6 centimeters. Give it a try. For those of you who are probably think that this is too easy, think about, is it possible to focus sound? If you can actually design a medium, focus sound. Sorry? No, because the thing, it doesn't literally, it's just diffracting the sound. It doesn't literally focus. It kind of like doesn't allow the sound to go elsewhere. What I'm saying about focusing is it passes through this medium and then the sound just converges. Converges there. Not that you don't allow it to spread.
The sound is a wave, always.
Should be bendable. Yeah, so how do you make it 10? Thing. Is it possible for you to produce a collimated beam of sound? Which means that when I want to talk to you, I only talk to you. That'd be really cool. I'm sure that I think it has been weaponized before. It's been weaponized. So you direct the beam of sound to enemies, disorientating sound, so they just collapse without killing them. Yeah. So anyone tell me what's the answer for the question? So 1 upon u plus 1 upon v equals to 1 upon f. Remember, this is negative 1 upon 6. Yeah, 1 upon v is equals to negative 1 upon 10. I think you're going to get 16 upon 60. So v is equals to 3.75 minus.
But you need to, but it's the distance between.
Which means the image is somewhere here, so you take 10 minus this. Careful, huh? I asked for distance between the object and the image. So it is 10 minus that image distance.
So it's 6.5.
Yeah. 6.25, correct. Okay? Cool. Now, for converging lens, remember that you can actually have a real image and a virtual image. For diverging lens, is it possible to have a real image and a virtual image? Is it possible to have a real image? No, you can never have a real image. So for diverging lens, it's very simple. The image will always be diminished, upright, and virtual. Always. Okay? So if you're given diverging lens, you should be happy here because it's only one case. Cool. Right, I think I will stop here for a while. Let's do some questions. I'll bring the notes up and then we'll do some questions and then we'll move on to mirrors.